Good morning. My name is Lawrence. Um, Good morning. My name is Nola Esmeralda, and today we're going to be experimenting with the traveling plane. Wait, hold on. He won't leave me alone, so I have to include him in the video. This is Max. Say hi. Today I will be showing you a bit of my magic trick regardless the dangerous fire that can travel not just through flammables, however to the dense smoke. Now let's dive into the wonders of fire. And Max, stop! Do you guys ever wonder how fire spread quickly in a dense area? It is not just due to the flammables, as some houses still catch on fire even though they aren't made of wood. Is it magic, or is it the beauty of our dangerous friend fire? That is what we will be finding out today. The materials for this experiment that we need are 2 candlesticks. I have a smaller one here from a house blessing. I just got it home. This one is actually for undas. Any flammables, preferably a lighter. And I also have a tissue paper just to catch the waxes in case my mom's going to kill me if I got the wax on this counter. And then a cup. I couldn't find a cup. And also it has to be glass because else it will be catching fire. You can't lose plastic cups. The experiment, of course, should be conducted in an open space where there's open windows and an open area. The reason for that is because in case anything else catches on fire, we can actually easily go out or maybe try and put out the fire without suffocating through the dense smoke. Well, to be fair, it'll be hard to put out a fire if there's a dense smoke. So here's my emotional support in case I actually burn down this apartment, and I can always blame it on him. Whatever. We just put one of the candles on the counter. For this case, I don't have to wax it on the counter because it has a surface for it to actually just stand. Not that I have that. In case you don't have a tissue paper to stop the wax, you can just get a scraper, any scraper, maybe an old nail cutter. You can use the ends of it to scrape the wax later. The only problem is that the counter would actually have marks on them. Either way, just make sure the surface is not flammable. It should be either concrete or tiles. Else we won't have any house to protect us from this excruciating heat rays. Why do you keep falling off? First we have to light one candle. I have to put this in the stand first. I had to introduce Boober as my assistant because he's the one who's holding the camera right. And also I'm actually doing this at the most dangerous place in the house because there's an LPG right here. So I have to move it first. Make sure you're not near any flammable or gases. Else you might blow up to it is probably shredding. I moved it. If you ever wonder where I'm sitting, I'm currently sitting on my brother's barbell. Slide it up. Okay, there's fire now. Now we can burn down the hill. I lit the wrong candle, didn't I? No, I actually lit the right candle. Make sure it's slanted and devoid of any air. We're just going to let it out of there. Because there's a fan right behind me. Or else I'll die. Please don't fall! We actually have to wax it now. Cipher is still holding it. If you're wondering, it is painful. It's got burned by fire. Used to. Many times. How and why? I was a very curious child and I like to experiment. Of course I failed first try. The reason for that is because the smoke isn't too dense. The smoke has to be very dense that you can see it right in the camera. Else, it's not going to work. There we go. It actually worked. Do it again. That is how fire spreads. We have to do it again for the video. How far can it go? It's awesome. You have to figure out because I saw it can go farther as long as it's open. It's dense. The only problem is the smoke we're making is acids. Because there's power behind me. I can't remove it. So I'm also don't light up yet. It is going to get this thing for this Oh, fans are getting it. Wait, what is going this way? And this one's that's different. It's not like playing fire with fire. It's not working anymore. The fan is getting it. Okay, if it goes this way, no interest. First, we're at home. You actually have to chase the smoke. Mostly to fire. Actually, the smoke's element being not really a solid thing. So it's very hard to keep it. How do you wash this? Water. Just wash it with water and then scrub it. That's all you have to do and it's good to go. Just make sure to actually put some warm water inside it too in case. Now we can do it. So we established that fire is dangerous. It did fail a lot of times. However, mostly it's still possible so long as there's dense smoke. Our smoke is not just too dense, so it's not truly producing that much that it actually needed to relight the candle. The candle. So why does flame travel through smoke? Well, here's the explanation. We know that smoke is a CO2 and particles from the flammables, which is the candlestick. This is the candlestick thing. It's kind of a rope. From those, it produces a smoke. The cup mostly prevents the smoke from coming out yet. So it's just going here and it's trapping the smoke inside, and when it came out, when you lift the cap, it's going to spread the smoke. And you can light that smoke and then you can relight the candle. So that's also a nature the fire uses to actually burn down houses. Its detonations travel through the smoke remnants, making it difficult to put out a big fire happening in a neighborhood as smoke becomes denser, making it harder to breathe. It's not just making it harder to breathe, it's also causing fire to have more paths and more reason to actually burn down more flammables. For example, your curtains. There's curtains. We know when CO2 is involved, it's way more than like 40 degrees or 46 degrees, right? So those smokes, it isn't hot if you touch it, but it is still kind of very, very hot. It's kind of cold today, so the magic trick isn't working. However, if it's kind of very, very hot today, it's like excruciating hot. It will actually work more often since heat travels better, fire travels better with heat. And if it's very hot, the smoke, of course, becomes much less colder and much less poisonous. This is also what of the famous solar flares are. Aurora is a result of a solar flare that travels through the pole. So we know Earth is a sphere, but I don't have a sphere, so we're gonna go with this. My footer stumbled. Let's just hope he doesn't find me. What are you doing there? So we know this is the North Pole, this is the South Pole. North Pole and South Pole. When the sun solar flare kind of travels, there's many solar flares. Actually, it's not a rare event; it's an often event. Some of it is just not reaching us most of the time, or it's due to our barrier that we're not actually having it received here. So long as this magnetic barrier is up, we're not going to die. Think of those magnetic barrier as a smoke path. The edge of it, I meant the surface part of it. Those smoke paths, this travels to here and here. So when the sun ray hits, it doesn't go inside it. As we know, we tried it. We tried to go around it, but there's a specific spot for it where the smoke is dense. It's similar to this. The smoke isn't dense. The thing isn't dense in the center. It's dense at the sides. So when a solar flare hits, it actually just goes or thus creating our famous aurora borealis. Why, you ask? Well, it's actually CO2 still, not true CO2 element, but it's more on heat, which is the same principle this uses. Heat is how fire is active. This beautiful for our ozone layer anyway. It's not just the smoke, it's also the denseness and the less denseness. It's basically how volcanoes are generated. So we're gonna try trivia time. The patterns of the sun mini flares and helixes are mostly using the dense CO2 through it. Thus, it kind of looked like a magical thing up close. So if you don't know, sun has this mini solar flares. It's not visible for us at this distance, but it's visible if you see it up close. It's not that close to the point you're burning, but it's just up close to the safe distance. You can see it right if you do a telescope. There's solar flares those are just mini solar flares. The solar flares are when it leaves the sun, actually, and travels elsewhere. The mini solar flares, meanwhile, doesn't even leave the sun. It's just creating this beautiful semicircles. So like a 180 in a pie. This traveling flame method is used actually as a torture method once by putting people inside something, then igniting the weed inside. Of course, when you're inside, you're trying to put out the weed. However, it's an enclosed space. In any chance that you actually are able to pull out the weed, pull out the fire, there's a hole there that the smoke comes out through. Since it's in an enclosed space, the smoke kind of go through there, and then they light it up, and the flame will travel, and you will burn again, no matter how many times you put out the fire or repeat on the weed. That's not going to work actually, since there's a dense smoke. So it's an easy method to kill someone, because if they don't die by fire, they can die through the dense smoke. It actually can be used as an assassination attempt since it doesn't leave a trace. So there's accidents recently that houses go up in flames, so there's no actual source. For example, there's no electricity that kind of blew. There is no source of flame that could have lit it. The reason for that is, in a house there can be no fire, but there's a dense smoke that's spreading inside the house that is kind of at a degree 45 to more than 45 to 50 in Arizona. Those heat, well, they're kind of a very source of the fire. So in case someone else is actually lighting a flammable, for example, I'm here lighting a flammable, a lighter, whilst the neighbor's house is full of kind of not gas but smoke only. It traveled here in a thick sense that I can see. It's like foggy. Then if I light this, their house is going up in flames. Same with LP heating if you're in an enclosed space. It mostly happens in Louisiana or Arizona. Fun fact. But yeah, in conclusion, don't play with fire. It's so dangerous that it can cause a house. You can play with it in an open field, actually. Like, I am playing in an open field right now. It is. I used to when I was a child. I used to go out in the forest. I am somehow confused. I didn't cause any forest fire, but mostly because of the humidity of the forest in our area. Now the forest is kind of gone because of the houses. You should just not play with fire inside your own abode, because trust me, it's not good. It's not worth it. Fire is fascinating in many ways, as heat was one of the kickstart of the universe that caused cosmic inflation, and later the Big Bang before the things cooled down enough for things to really form. For example, cosmic inflation you start with this, and suddenly with this. That's because of the heat explosion that travels through an invisible path, which is the invisible path are similar to smoke. See, the traveling flame isn't just a one-time thing in the smoke or a dangerous thing, it's also the start of life. As how else does electron travel through the universe? To spread it equally and have no dark matter yet, and thus causing the Big Bang, and then creating many suns, those suns, creating more suns by dying supernova. And now I have to. I should probably scrape this while I'm talking, or else my mom might go home. Yeah, traveling flame or ghost flame is basically one of the reasons the universe was kickstarted. Heat may falter unlike the cold, because that's true. Heat isn't forever. Everything with heat will die down in the future. Actually, unlike the cold that is actually forever once everything is gone, it'll be just a cold, vast space. It is a source, but heat is a source we rely on. Too much of it is not great. I'm not good with endings. So you can just watch me scrape here. Or you can help me. Just say meow. Why won't you leave me alone? You could just help me scrape this up.